Hello, everyone. Welcome to our webinar today. I'm here with my colleague Viktors. My name is Costa. I'm the founder and CEO of Quicksurface. In today's webinar, we would like to take you through the what's new in Quicksurface 2026. We're still waiting for some more people to join. I would like to let you know that this webinar is being recorded and we will upload it after this on our YouTube channel. So for whoever missed or someone wants to come back and watch it again, you're welcome to see this. If you cannot find the link on YouTube, just drop us an email. You can always contact us at support@quicksurface.com for any questions that you may have. Like every webinar, we have a Q&A session. We will go through our presentation. I will just show you briefly explain what is new in Quicksurface, but then Viktors will jump in and show you all the features in actions. So please use a chat. Actually, it's preferable if you put everything in a Q&A window, which you can find at the bottom of the control panel. You can raise a hand if it's needed, if it's something super urgent, but I hope that everything will be really clear and nicely explained by us. So we'll have enough time for the Q&A session at the end. So it's already 1 minute past, so I will just start my presentation about the Quicksurface. Welcome everyone, and thank you again for joining our webinar. Before I begin, I would like to say a few words about Quicksurface. The reason for doing this is that some of you may have joined this webinar for the first time. Maybe they don't have idea what is this. Maybe other people are very advanced in Quicksurface, which I'm very happy to say. I can see familiar names in the attendees list. But still, Quicksurface is a standalone application which stays between your 3D scanner and your CAD packages. I hope this diagram explains this very simple, but what Quicksurface is taking 3D scan data as meshes from any 3D scanner, and then using the tools allows the user to create a perfect CAD model, which later can be used in any CAD or CAM packages, as you can see on the right side of the screen. Even more, when you complete this, our product can be used directly for 3D printing or CNC machining without any need to go to any additional CAD package. But also what it is in terms of functionality. It's just a professional, powerful, and intuitive software that allows you to take the scan data, apply different functions, some of them which are smart algorithms and based on AI technologies, and allows the user in a simple way to have full control during the whole process, that he can start from the scan data and generate its final model. As you can see on these images, I try to list some of the objects that we have created, but there are so many capabilities that you can do with the Quicksurface. For those who are just new in our technologies, I would like to explain what actually is the workflow, how it actually works. The normal way you do is standard for every approach that you apply to when you do reverse engineering of a CAD model. Once you import your scan data into the software, you need to follow a couple of basic steps that allow you to achieve the best results. And in this diagram, we just try to summarize what these steps should be. For example, when you bring in the scan data, you need to align this object into space. Why? Because this is a fundamental step in every CAD modeling. Without alignment, you cannot continue and create a perfect model. For this reason, Quicksurface provides a lot of intuitive and simple tools to be able to create the primitives with a perfect accuracy and with the full user control to take decisions whether this needs to follow your design intent, or it needs to follow the maximum accuracy of the scan data. After that, in a traditional way, the software allows you to create different features, and these features can be like extrusion, revolved, but also a lot of advanced features that you find out in the software and also in today's demonstration. We have a state-of-the-art trimming tool that allows you to quickly reconstruct a solid or it's a single surface. And with the power of freeform modeling, which is one of the very unique features of Quicksurface, you can create a hybrid type of modeling, which today's it's very complex or it's even impossible into any other solution. At the end, using our deviation analyzer, you can have control of the quality if you have achieved what you need to achieve in terms of accuracy, or you want to achieve in terms of as a design intent. Once you complete your project, you can export this, as I showed in the previous slide, to your next CAD package, or you can send it directly for the 3D printer or a CNC milling machine. So this is the basic workflow. I hope you get the idea on how it works. But more about this you can find on our website at any time by visiting www.quicksurface.com. Moving further, I would like to go and explain more about our development for the past year. It's been really hard for us, even if we were quiet on providing any new updates on 2025. We've been really too much involved in our next goal. This means to enable a way more capabilities of the software by using a state-of-the-art Parasolid CAD kernel. For some of you, this probably doesn't mean a lot, but the Parasolid CAD kernel is a library which is used in leading CAD packages such as SolidWorks, Solid Edge, and other top CAD packages, which allows you to have a lot of flexibility to generate CAD model. We wanted to combine this proven technology of Parasolid, of Siemens Parasolid, together with our dedicated tools of reverse engineering, which we are expert in, and combining them to deliver a really powerful package. Having this in Quicksurface 2026 allows us to overcome a lot of problems that we had in the past, but at the same time deliver a great experience for all the users and be able to achieve results which otherwise you cannot achieve in any other different approaches. And the last but not least, we always continue to drive our efforts to provide a great usability, and I'm very happy to say a big thanks to all the people who supported us over this year. I would like to encourage you to visit our group and contact us on our contact email at support@quicksurface.com. And if you have any ideas, any problems that you try to solve, just don't be afraid and get in touch. In details, now what is new in our new version, I have listed here a lot of tools which for some of you may sound quite boring or quite standard tools, but believe me, once you combine them with the use for reverse engineering, they give you a great tools in your hands to make amazing project. The tools that we have are, we paid a lot of attention to the flexibility on the filleting, offset thickening, shelling, lofting, moving faces, and so on. And at the end, you have all this power in your hands. So this is really what we did for the last year. I'm moving now and would like to hand over the presentation to Viktors, who will share his screen and will jump in and give you how all these tools that I mentioned here work in practice. So over to you, Viktors. I'll just stop sharing my screen and then you can take it.
Yes, hello everyone. So yes, basically we had quite a lot of job during the past year, and we have developed a lot of new tools. And the very first one, what I would like to talk about is mesh trimming. Basically, if you want to recreate some objects, for example, with automatic freeforms, and you have to split your mesh somehow to create like proper surfaces around your molds or something, and then mix this together with automatic freeform surfaces. Essentially, this is way easier than just to select some polygons inside of your mesh and apply automatic freeform over it. You can just trim it, and at the same moment, you will get pretty precise edges of your generated freeform surface. So this is pretty nice approach how to do this. In the new release, we have option to trim surfaces, not just with some geometries like solids or surfaces. Now we have option to trim our meshes with 3D sketches. So just couple words how this works. Basically, first you have to go to Edit Scan. Here you click on Split Mesh with other solid, surface, or mesh. And this will automatically select your 3D sketch that is active in your window. Here you can see the offset value of 1 millimeter. So what this exactly means. When you have created your 3D curve here, 3D sketch, you can see that if you change this value to, for example, like 2 millimeters, it will create surface which is perpendicular to your scan data. And we have had quite several questions from users why this doesn't work. So normally you would have to press preview. It would process and show you like two meshes for in this case, where one would be in one color, another one in different color. So, and pretty often there are cases that people start to complain, oh, well, this doesn't work somehow, just because of something. And there is a problem mostly in user. So you don't create these 3D sketches precise enough. And in some cases, this 3D sketch like goes under your sketch, not sketch, but your mesh data. And this deviation between your 3D curve and the mesh data is greater than offset value you have set. So here you can see it processed, but you have nothing here. So reason here is exactly what I described previously. You can see that 1 millimeter offset is not enough to completely intersect your scan data. And if you select this like for 2 millimeters, now you can see it intersects this completely. And if you click preview right now, so now you can see that we have like two separate meshes. This in case when this works. So if you click cancel right now, cancel everything, we can go to edit our 3D curve. Here we have our deviation control. And here you can see that our set deviation is 0.1. For example, if we set this 0.5, you can see that it's still somewhere under there. Just go back to 0.1, and what you can do, you can just come over, click twice, insert another point here, move around to get everything green within your proper deviation. And after that, it will work just fine with like 1 millimeter offset or something. So another problem here is actually a problem that I want to discuss. Sometimes users try to do this following way. So I don't know how, probably you have zoomed out too much or something, you start to add your points of 3D curve somewhere. This, probably there. Okay, so at this moment you can see that this 3D curve actually jumps from one vertical surface to this mold flange. And if you go over edit scan, and you can see how your surface is being created. So since it's always perpendicular to your scan data, it starts to do some tricks. And in some cases, it might get like too down somewhere or twisting completely, and also it won't produce you any meaningful result that will be able to trim your surfaces, not surfaces, but your meshes. So like, for example, this place. So just be patient and be careful how you're creating these 3D curves if you want to trim your meshes. That would be all about mesh trimming, I guess. We can move over to our next topic, and this is selective symmetry plane. So as you know, probably, hopefully you know, we always have had, okay, not always, for the past year we had feature called symmetry plane. So basically you were able just to drag some line, reposition it a bit somewhere here and there, then click rebuild, and it would calculate something. Not something, but actually it will calculate the symmetry mesh based on your scan data. But in automotive world, there's quite a lot of questions from users, from scanner users, how actually to align complete cars. So here you can see how this worked just with simple algorithms of symmetry plane, where it takes in calculation like completely all the points. And if we are coming back to our topic of selection-based symmetry plane, this works a bit different way. So you go to edit scan data. Here you can choose just some regions that you would like to work, or some regions that you assume you want to use for this symmetry plane. For example, here you probably want to work around your arches to create some over fenders or something. So you want to establish the symmetry plane so these regions are symmetric. Because the real fact is automotive world is not perfect. It's super far from being perfect. And if you want to create symmetry for these parts, it won't be symmetric to some different parts of your car, because from factory there's quite big deviation. This is like first, secondary, you never know how this car was abused or something, so the chassis might be twisted or something, or it was probably after a crash or something. So there are a lot of different things that can leave some impact on symmetry of this object. So basically here you select what you want to use for creating your symmetry plane, click close, go back here again, go to symmetry plane, do the same, just draw some line, which is more or less eyeballing. You can reposition this slightly so it calculates faster. Click rebuild. Here you see the message that software is going to use only selected triangles to find the symmetry plane. Yes. Here you can see the symmetry plane created based on these selections. We can go to analysis. and see that, for example, green means we are symmetrical over these patches or these panels on both sides. But we can see that front fenders are quite off somewhere. Of course, you can always come over here and just reposition your symmetry plane if you know that it might be better or something. So you can experiment with this. Let's create this one. And I will create another one just to show you example how differently this can look if you select some different parts of your cars. So this time I'm going to use this side cards. Go symmetry plane. Rebuild. See analysis here. So you can see how different results can be if you're selecting some different portions of your scan data. So that means you can never know how perfect your car is, and you have to understand that if you want to work on some exact places and they have to be symmetrical for your designs, just use these options and create your object or reverse engineering parts based on different symmetry planes in different locations of these chases. Now we could move over to our next topic, which is draft surfaces. This is something new also that we introduced in our Quicksurface 2026. Basically, it's quite essential for casting parts. It's likely they will have quite a lot of drafts everywhere because of the nature of how this is being manufactured. I'm going just to hide this and talk about draft surfaces more in detail. So let's start with just a simple sketch. Essentially, this file is going to be a little bit slower than typically we're running because it has quite long history tree already, but it's going to be just fine. So, for example, we can see that here, basically, we have some drafted surface. So we come over, create our sketch as we are typically doing this. Okay, let's say it's a circle. Hit extrude. So here is something what is different from the previous versions. We can see the analysis function, and it works not just for like snapping to your mesh at the end of extrusions, but you can actually see your actual deviation on the side walls as well. So here you can come over and start moving draft angle slider and see and find your perfect draft angle for these parts. After that, you can just go lower. Here you can see that it changes. So obviously there is something wrong around this place. So you go just there, and after that you can, okay, let's say we can create sketch here and just project the surface and extrude from this side. Here again, you can just play around the slider to find the perfect deviation. So you can see on the top side we had 1.5 degrees, and the bottom side is obviously more, something close to 2 degrees. So this is how draft angle finder, let's call it this way, works in our case. And this is like first feature I wanted to talk about. This is super handy in some cases where you have unstable geometries. It works even much better, and it's nice to have this deviation control while you're doing everything, so you can just adjust your geometry on the way. Next thing would be, say, I'll just create simple shape here. Or something. Let's extrude this so we can see. Again, we have to use some draft angle in one of the directions. Okay. So I just created this, not the green. It didn't match it perfectly, but I adjusted the angle so the color plot is one uniform color, more or less. After that, I can see that, okay, I'm here a bit off of initial surface. What can I do? I can come over here, select the surface, go to CAD, and move face. This is our next thing that we introduced in our new release. So we have two options. It's like move based on your coordinate system or offset. We can switch on our analysis, and as you start move your slider, you can see that your surface is being moved to one or another direction, and you can actually hit the desired deviation as you want this to be. Another thing is, for example, if we set it from here, we can see that this top surface also has some draft, quite a lot of it. So how can we actually deal with this? Okay, if this is just a square block, it would be easy. You can trim this from the side view. But if it's not just a block, it takes like bigger shapes or something. How can you deal with this? You can just find some random extrusion height, for example, like this one. After that, I can go again to CAD tab, go to draft. Here you have to select your base surface, which will be used to draft all the other surfaces. I'm selecting this one. And now I have to select surfaces to draft. Obviously, I want this one. Switch on analysis. Basically, at this point, it removes any draft from your extrusion. And as I have previously used draft on this side, it was like bouncing outside. So draft on this side is quite good at the moment. But you can always turn it up or down, depending how much do you need. So this way you can get like perfectly aligned surfaces to your scan data. Okay, so another thing which we might showcase probably if we go with this main model. So for example, you have created all these features and you just want to extend this face, so you can go select this surface and try to move them to one or another direction, and you see how it grows depending on your needs. Or you can move them manually based on your coordinate system. So where's the difference? In this case, this face is perpendicular to your coordinate system plane, so it's easy. You can move just with arrows here. But for example, if you would have your surface, this one, go to move face, you can see that your coordinate system is placed in different directions, so you can't actually use the normals of coordinate system to move this face somewhere. Otherwise, it will create just some weird results in most cases. And we have quite nice option to rotate these surfaces as well. Just okay. So you can actually see that the surface is being rotated to some different angle for different needs. I don't know, probably you want to recreate this with some different connection or something. So just as idea and what you can do with our new tools. So at this point, I think we can just jump to our next topic, and this would be shelling and thickening. Both of these, let's say, actions can be performed pretty often on various parts that you see around. These are typical caps, typical geometries where you don't have like variable thicknesses or something. For example, this cap. I'm going to hide this one and just unhide the block, which is like halfway reverse engineered part. And in this case, I want to show you how works our shelling. Go to shell, select surface you want to eliminate during the shelling, and just start to move your slider. Of course, we have analysis options here. The far as you consider this is the good result. This scan data isn't like super perfect, or maybe part itself wasn't great as well, but general idea is this. How can you do this pretty quickly? So you don't have to create another set of surfaces inside and trim all that together to get rid of this internal volume. I'll click OK here, and I'll jump to topic about thickening. So basically here I have just outer surface, and both these actions looks super similar one to each other, but there is one slight difference in them. So if I'm creating just thicken, thicken, I can create nearly same part. In most cases, you don't see much difference here, but difference is in following case. So you can see that shelled part have this completely flat surface here, which was used to create this solid part previously. And if you look at thicken, here you can see some weird lines that are splitting our faces. If we come over to this view, you can actually see that thicken isn't same flat as the shell, which had flat surface in this region. So reason for that is when you are creating thickening, it always thickens perpendicularly to surface. So it's normal to surface. And in this case, our outer region of this part, our surface, it's not like completely vertical. If it would be completely vertical, we would get the flat surface on the top. But as it's curved, and this curvature doesn't match like verticality, we are getting these different shapes on our top surface. Basically, this is the main difference in between these two. Of course, you can't shell surface. If you have some Pender layer or something, you have created your outer surface, it would be quite a nightmare to create this as a solid block and then shell it. In this case, thicken is your like best way to go. Okay, so this would be about thickening, and we can go to our next topic, which is variable fillet topic. So here I have this one quite simple part, but this is going to be good enough for you to understand how works our variable filleting. And this one, I have prepared some set of surfaces. So as typically you go to fillet some edge, start pull it down. You see that your fillet doesn't actually match all this corner in all the region. So what you can do, you can just find one side, for example. Okay, it's good on this side. Then you can switch to variable fillet. So it keeps the previous dimension of radius. And you can start to play around on the other side to expand this. Okay, I have good on this side right now. I can change the dimension on this side. Okay, but at the same moment I have this a larger deviation on this middle zone, so I can just go and add another point here and adjust this as I need. So in this case, we have 3 different dimensions for one filleted edge. Also, sometimes you may fail and just add this point somewhere where it's not matching that good as it could be. So you can come over and just move this around. Probably this will be easier for you to find the perfect place for this. Probably later you want to add one more point here, for example. Readjust so you can get even better results for this case. Also, of course, you can change the shape type from circular to curvature continuous if this is some more fancy surfacing part, or you just consider there should be the curvature continuity in this case. But in simple cases, this is just what world needs to be. Let's move to our next topic. This is going to be about lofting, about blending, and some fitting surfaces. So probably you have seen these pictures probably somewhere. Not sure if we have shared this or not. So how this is done? Basically, here's a set of 3D curves. Can go to surfacing tab, click on fill surface, select this selection, click on scan data. We can take a look at analysis deviation. this. After that, we can change some UV count here to match it better, like this. Okay, let's create this one. Let's fill, for example, this. And we have to change, for example, for 10 by 10. Probably maybe 15. Depending on your geometry. Of course, this is not the greatest approach for all the possible parts, because in automotive case, if you are looking into something, how this is done properly, you would have to create here many different surfaces and to mold them together to find the super perfect class A surface. But as you can see, in this case, we're quite close to actual part here. It's like 0.3 millimeters. So these might be even bumps on the actual used part or some painting defects or something. So this is on your side to decide this is good or not. Let's fill this last one. Just with some, let's say, let's keep it just like this. On this side, we have much more complicated shape. So we have variable curvature here, and it's much more difficult to fit some surface here. It's doable still, but we can use loft tools. So in our latest release, we have included lofting that include guide curves, so you can have, for example, your profiles, select several profiles, and then add your guide curves here. See how it matches. So you can, if it doesn't match, you can add more guide curves or more profiles or something. So this is quite a lot expanded flexibility for these tools. Just get this one, flip it, and at this moment, another updates of lofting. Let's say, let's start with this one. So we have, as typically always, we have curvature settings. Here we can see the analysis. Another thing, we can play with tangency weights to control our surface. For these cases here, you can see, okay, this matches pretty good, but for example, if I pull here completely to like green, we're getting here different deviation. And for example, we want to get rid of this. So we can just split this loft in half by moving our vertices here, control points. Can play tangency weights on this side to get it closer. So now it's perfectly green. You can come over here, select two edges and select this edge as a guide curve. Set this to curvature. Again, by changing tangency weights, we can get absolutely different results. At this point, probably we want to introduce another patch over here to match our deviation better. For example, the last one we can create just as it is. Probably in some cases you won't like the fact that your surface are getting the curvature control aligned by these edges. So you can always move a bit aside more aside to get your tangency perpendicular to your surface, not based on your edges. This is another part of flexibility that you can display how it's possible. How can you imagine this to happen? So, okay, this is about this part. Same goes on these longer blends here. So as you can see, the one side is pretty good and green, matches deviation grade here as well. But in the middle sections, we have quite different deviations. So essentially, we can just come over, pull our control points to a region where we want to change our tangency. This, or probably you will want to create this from like 3 patches. Something this way. And just reposition them as it's better for you. So this will be shortly about lofting. And I would like to jump now to our next topic, which is surface flattening. This is quite interesting topic. We had some basic surface flattening in our previous release as well. And we have updated this flattening. So now it can flatten much more complex surfaces. It keeps much better the internal cutouts or holes or something like that. So essentially you can just see how this works here. Let's go to flatten. Let's pick, for example, this point. So you can see this flattened previously created surface. If we go to analysis, so here we can see actual how this flattening happened here, and in some regions where you have higher curvature, for example, in different directions, in 2 directions, you will always have some stretching or shrinking. So in this case, you can see how big this shrink or shrunk is, and you can estimate, for example, if you are using this as for decals, this might work. If you're going to cut this part out of sheet metal and try to bend it this way, this is going to be much more complicated than just to wrap this around, for example, in this region. Here it will just work completely fine, easy. In these regions, most likely you will need some proper skills to do this. Okay, this is about our flattening, and
I think we covered most of the features. So
yeah, exactly.
maybe I will just jump in. Thank you, Victor, so much for all this detailed presentation. I really enjoyed. Hope you also. For some of you, some of the tools might look a bit more advanced, but I hope you still like them. I just need to share my screen now, get back, and if you allow me,
Yeah, yes, of course.
Just allow me to finish my presentation, and then we can jump into the Q&A session. Quicksurface 2026 offers a lot of power, and it's really hard for us to demonstrate in this couple of minutes. Victor's tried to provide a lot of detailed features, but I'm sure if you just download the trial version, you can explore yourself. Again, we are available if you have any questions or any needs for any specific function. Feel free to contact us and we'll be happy to help you. But I hope it's quite intuitive, especially the real-time analyzer. We spend a lot of time to improve this, and this makes the things different from what we are doing and what we add as a value. I would like to say a few words about the upgrade for our existing customers. As you can see on the screen, If you purchased our older version and you are still in your 1 year window, you can get the upgrade for free. This is our policy, which means that you are still under maintenance, or you can optionally purchase a maintenance that will allow you to get the new Quicksurface 2026. We encourage you to download and at least evaluate and see what it's about. We have a special offer until end of the year. So you can see on the screen that until 31st of December, you can purchase the Quicksurface 2026 at the current price of what is Quicksurface 2025. So that's all from my side as a presentation. You can again find a lot of information on our website. Feel free to visit and read everything about it. We have a trial version. You can just press the button at the top right corner, which says free trial. Feel free to explore. You have 30 days to evaluate the software. Now I'm moving to the next stage, which is the Q&A session, and I'm happy to answer your questions. There is directly question, how much is the maintenance from 2024 to 2026? Normally the maintenance, how it works, you just cover all the years that you've missed, and then you can just get the new update. If you are unsure if you're still under maintenance or how many years you've missed, you can just contact us and I will provide answers to you directly. On the flattening, is there a way to add relief cuts? At the moment, flattening is primarily for this type of stickers, as I say, so there are no cutouts at the moment, but perhaps with your feedback, if you provide us some information, we will implement this in the near future. How do you add segments in the loft function? Okay, I'll just read this loudly. It's how do you add segments in the loft function? You had points on the edges. How do you add more points in the middle of the loft? Well, you just slide your points that define the surface of the lofting, and then you create one loft, then you create the next loft next to this one, and so on, and you just build up your surfaces, and then you have a control that can be curvature continuous. So if you are unsure, you can try, and if you have specific case, you can build up, send us the project file, and we can discuss together and can show you how it works in Quicksurface. No, we don't have internal points to add. You just need to add this manually and create different surfaces. Okay. Any more questions? I answered some of them live. Right. With the new Parasolid engine, are the solids generated natively will be recognized natively in SolidWorks? Yes, if you export the file as a Parasolid, because the new Quicksurface, instead of exporting step or edges, if the other software supports Parasolid, we recommend that you export the file as a Parasolid file. Then it will natively be open in your other CAD package like SolidWorks as a standard Parasolid object. When you say cylinder recognized as a cylinder, don't get me wrong, there is no such thing like a cylinder in SolidWorks. There are extrusions and revolved. I've never seen a cylinder. But you can pick on cylindrical face and you can define an axis, or you can measure it as a cylinder. So it is recognized in SolidWorks as a cylinder, yes. about the tutorials, yes, we'll be working hard to improve our tutorial page and add all the missing functions with the 2026 version feature set. Yes. On Quicksurface 2025 filletings fails to perform. Is it now optimized? Yes. The answer is yes. Because of the Parasolid kernel, the whole engine behind the creating of fillets is completely different. We rely on the all the development of Parasolid that have created this filleting for many years, and they have done really great job when they do a filleting, and you will experience you will overcome all the issues that you've had in 2025. And one of the main reasons to move to Parasolid is one of them is also filleting, shelling, and thickening, and all the other amazing tools that they provide, such as move faces and so on. We will be at Rapid TCT 2026. I'm happy to share, yes, we booked our stand, and we will be at Rapid TCT in Boston this year. Not this year, the coming 2026. Yeah, you're welcome to visit us. We'll be very happy to meet you in person and say hello and or exchange ideas. Okay. Okay, I just see greetings from our friends. Again, thank you. And as a reminder, you can always find information about us on our website, but we encourage you, if you're using Facebook, to join our Facebook group where you can share your questions, your concerns. We created this group to be a place where enthusiasts, people who know already Quicksurface, are willing to help, and also for other people who need some help to jump in and together with the whole community be able to answer different questions. Also, this is a place where you can place your requests, problems, or wishes that the way you want to our software to improve. So we're trying to build our community there. So everyone is welcome to join, and I'll be very happy to see you there. There is a question about extending the trial. We always try to support if you need a couple of more days to evaluate the software as you are unsure, then contact us and we will do our best and we will extend. At the moment, I don't see any more questions. Thank you very much for all the kind words that you place in the Q&As. They are not questions, but I'm very happy to read them. Again, I would like to say a big thanks to Viktors for the presentations, and we'll see you soon. Thank you, everyone, and I'm going to stop the session now. Thank you, and have a good rest of the day.
Okay, see you.